Today we'll be solving Leetcode 560 Subarray Sum Equals K. So, given an array of integers num and an integer k, return the total number of subarrays whose sum is equal to k. So, we need to find out total number of subarrays. So, let's see this example. We have nums 1, 1, 1. So, what are the subarrays we have here? We have only one subarray with 1, another subarray 1, 1, another subarray 1, 1, 1. If we start from this one, then we can actually start from the next one. So on the index 1, one subarray only 1, another subarray 1, 1. And the last one, when we come here, we have one subarray 1. So what we can see that brute force approach, we can use two loop I and j, and I will be initialized with 0 and j will be also initialized with I. So that would be our brute force. So for each of the I, we have a j. So initially I and j equals 1, that will have our single one, then j will increment. So ON square solution is the brute force solution for this one. We can find the subarray and we can sum them up and we can check if that is equals to our k. So can we do it better? If we see the pattern of this problem, then we'll be able to see if we can do it better. So let's take another example. 1, 2, 1, 1, 1. So what is the running sum for this? Here, running sum is 1. Here, 3, 4, 5, 6. So if we use a hash map for prefix sum, and count of sum, and another count is to keep track how many subarrays we are getting. Say this is 0, and here running sum is 1, right? What is before that? Say there is a running sum of 0, count 1. I'll show you when we'll require. And this is a subarray sum of 3, right? If k equals 3. So what would be the prefix for that? So here the sum of this array to be 3, the prefix should be sum or running sum minus k. Sum minus k equals 3, sum minus 3. So 3 minus 3, 0. So we need a running prefix sum of 0 here. If the prefix sum is 0, then we can start it from here. 1, 2 is a subarray sum 3. So for each of the position, how we check that if there is a subarray sum of k at that position, we need to do running sum minus k, which is our subarray sum equal should be. If we find one, then that is a subarray. not only one, if we find more, like if it is big and we have lots of element here, if we find this zero multiple here, that means there was a subarray sum 0 here, there will be more subarray. So we'll show when we code. Now we got a subarray here for 3, and when it was 1, 1 minus 3, that means minus 2. We don't have a minus 2. So we move on to the next one and keep count 1 for 1. We have a prefix sum of 1 of count 1. For 3, we do 3 minus 3 is 0. So we have a 0 here, which is count 1. So we add this count here. For 4, 4 minus 3 equals 1. Do you have a running sum 1 here? Yes, we have here. Since we have a prefix sum here, that means from here to 4 to 1 is our another subarray where sum equals 3. So for 4 minus 3, 1, we got one count of 1. So we add this 1. We had one subarray here for 3, and now for 4 we got another subarray. For 5, 5 minus 3, 5 minus k, 2. There is there any, there is element 2, but if there are any running sum or prefix sum 2, there is no prefix sum 2. So we just say we got a prefix sum of count 1. And then the last element for this index, we have 6 minus 3 equals 3. Do we have 3 as a running sum? Yes, we have 3 running sum here. That means we have another subarray, which is 1, 1, 1. So we for 3, we had a count 1. When we update the count for this, so for these positions we got 3 here and count 1. So we, now if there was count 2, we would add this count 2. How it could be count 2? If there was more element here and there was running sum 3 here. If running sum 3 here, you can see that because there is plus minus, right? These numbers are not all positive, there is negative numbers. So there is a 3, that means this is a subarray, and if there was another 3, then from these 3 to after these 3 to all the way this, whatever would be our subarray, if we sum up, that would be equals to 3. That's why we take all the counts and add with the count. So let's now go to the code and implement it. Okay, so we need to create a hash map of integer. We call it prefix sum, new hash map, and then we declare count equals 0. That would be our count, and we say return count, that will be returning, and our running sum, we initialize it to 0, say sum, And as I have shown in the code, right, we need to initialize the hash map for a sum 0 of count 1, because at the beginning there is no prefix sum. So we assume there is a prefix sum of 0 of count 1. And now we look through it. 0 I less than num dot length I plus plus, and our running sum plus equals num I. We add current element to the running sum, and if we check if prefix sum dot contains key sum minus k, right? That's what we have seen. If it does, then count plus equals prefix sum dot get sum minus k. That's what we do. And for each index, we update the hash map. So we say prefix sum dot put sum is our key, which is running sum, and prefix sum dot get. If we get that sum, get or default. If we get that sum, we get it and add 1 to it, increment it, and store it in the hash map, update the map. Or if we don't get the sum, we add the sum in the hash map with a default value 0, 0 count. So we format the code, and let's look at again. So our hash map count sum, we are initializing it with count 0, and we are updating the running sum, and if contains. So now what you see that here, if we have something like running sum, we have 3 here, we have something here, we have another 3 here, running sum, and we have some here, and here we have 6 as running sum. So when we say sum minus 3, that would be 6 if k equals 3, 6 minus 3 equals 3. So in this case, we will have count of sum minus k equals 2, because you can see that there is a prefix sum here 3, there is a prefix sum here 3. That means after this, from this to this, there will be a subarray, and right after this, from here to here, there will be subarray that sums to 3, because there is positive negative number together, right? So if there is negative number, it is possible, and this happens in this program. So let me run it. Okay, it passes the test cases. I have added 1 to 1 1 1. The test cases we are going through. Let's submit it. Okay, it accepted, and it beat 48.1% of other implementations. So what is the time complexity and space complexity? Time complexity is time complexity is on, cause we are just doing a loop for the num array from start to end, and since we are using a hash map, so inside the array for each iteration of the loop it is O1. So time complexity is On. And what was the brute force time complexity? It was On square. So we are making On square to On. And what is the space complexity? That is also On.